cetera, et cetera. But here's my favorite. Here's my absolute favorite. In your retina, you have a bit of a problem because the time it takes for the signal to go from your photoreceptor to your brain could be on the order of, let's say, a tenth of a second, a little bit less than a tenth of a second. Well, if you're playing tennis and you're playing, let's say, against a professional tennis player, a ball could go a whole meter in that amount of time. So what happens is you'll get hit in the head by the ball because what your brain perceives is not going to be where the ball is. But the retina anticipates where objects will be in the future, then sends that image to your brain. So the image that your brain perceives is where the ball will actually be when your brain perceives it. So it's incredibly advanced neural processing, which is pretty amazing. Now, what's fascinating too is one thing we're trying to show with our engineering group is that engineering insights and principles are very powerful in predicting what you'll expect in biology. They're very powerful in helping you understand what you see in biology. And I did a little experiment. I said, well, I studied neural networks, and I know for a neural network to work, you've got to have a training pattern. Any of you that are programmers know this. You've got to send like training data to teach a neural network how to set the right connection strengths between the different neurons. So I said, I bet if I look in the literature, I'll find training data. Guess what I found? Training data.